Hello, and welcome to Business Calculus Graphing Strategy. Previous videos have discussed the information about a graph that can be obtained by carefully studying the first and second derivatives. What we're going to be doing in this video is collecting that knowledge into a comprehensive graphing strategy that will allow us to make very accurate graphs of a function by applying our knowledge of calculus. We're going to be using algebra, limits, and the first and second derivatives of a function to sketch the graph of a function as accurately as possible. In order to apply this graphing strategy, we're going to develop a four-step method. The first major step in this method is to analyze the original function f of x. We're going to find its domain and record it in interval notation. We're going to do this based upon the properties of the function. For instance, if it's a polynomial, we're going to know that its domain is all real numbers, or if it is a function that has a denominator, we're going to exclude the values of x that make the denominator equal to 0, etc. We're also going to find the x and y intercepts of that original function f of x. We are going to find any asymptotes of the function, and we're going to use our knowledge of limits to determine the end behavior of the function. Step 2 involves analyzing the first derivative of the function f prime. First, we'll need to calculate the derivative f prime, and then we'll need to find the partition numbers of f prime and make the sign chart for the first derivative. Using this sign chart, we're going to determine the intervals over which the function f of x is increasing and decreasing, and also determine the local minima and maxima of the function. The third major step of this process is to analyze f double prime, the second derivative. We start, of course, by calculating that second derivative, and then by determining the partition numbers of the second derivative so that we can make the sign chart for that function. Using this sign chart, we're going to find the intervals over which f of x is concave up and concave down, and then we're going to determine the ordered pairs of any inflection points that occur in the function. The final step of our process is to collect all of this information so that we may sketch the graph of f of x. We start by drawing any asymptotes of the function, and then we graph all of the important points that we calculated in the previous three steps: the x and y intercepts, the local minima and maxima, and any inflection points. Sometimes this doesn't tell us everything that we need to know about a function, so we may have to choose some values of x to plug into our original function to determine any additional ordered pairs that we would need to graph in order to fill in our sketch. And then lastly, we use our knowledge from steps 1 through 3, namely the intervals over which the function is increasing or decreasing, or whether or not the function is concave up or concave down, to fill in the correctly shaped curves of the graph, including correctly modeling any end behavior based on the asymptotes or the results of our limits at positive and negative infinity. Now, there's a lot of steps here, and feel free to skip backwards in the video to collect any additional information that we need. We're not going to be doing an example in this video explicitly of this because, as you can see, this takes some time to do, so our written examples will be part of separate videos. So, take any additional notes that you need about the 4 steps in our process. We're about to ask a question about one of the steps. Alright, I would like to know which of the following small steps are part of analyzing the first derivative, f prime. Finding the sign chart for f prime, finding all local extrema of f of x, finding the intervals where f of x is increasing and decreasing, or all of these. Thank you very much for listening.